formats that the Google APIs are coming down in. So you can change those and model those to fit the way that you want to see them. You might want webhook streams. We've seen a lot of this pattern to be able to change the interaction pattern. This is not just hubbub and a view of the world, but specific APIs turned into a communication pattern that matches what you want for your application. So you can apply this pattern to make the APIs that you consume to make them look the way you want them. You can swap out provider APIs without breaking the application. A good example here are financial services companies. One in particular that I've done a lot of work with, TransUnion. They have multiple payment providers. They were dissatisfied with the first payment provider. They needed to move on to the second. Many internal applications were already dependent on the first provider's API. They simply used API virtualization to put a shim in place, make the new provider look like the old provider, change providers, and all that happened was a contract change. All the applications continued to work the way they were. So it's a way to get control of your dependencies as a developer as well. So if you virtualize the new provider to look like the old, you can change the provider without changing your code. So in summary, as I said before, we're seeing an architectural pattern emerge that deals with an expanding variety of computing devices and the exploding number of APIs in modern applications. It can be used on either side of an API, by providers and by developers. So in a nutshell, API virtualization takes the pain out of the API development lifecycle.